This is an overview of atmospheric carbon dioxide and particulate matter. According to a recent publication by the American Chemical Society, researchers found that ambient fine particulate matter with an aerodynamic diameter less than 2.5 micrometers is recognized as the leading environmental risk factor for the global burden of disease, with an estimated 4.1 million attributable deaths in 2016. Long-term exposure to high particulate matter adversely affects human health, and several epidemiology studies have reported adverse effects from long-term exposure at levels of particulate matter concentrations that are below the World Health Organization guideline. Given the gravity of this event, more is needed to understand the long-term changes in exposure and their implications for health effects research. But beyond that, a greater understanding of particulate matter and atmospheric carbon dioxide is needed by the general public. The learning objectives for today are to gain a greater understanding of how human activities have physical, chemical, and biological consequences for the atmosphere. The learning objective is to describe natural sources of carbon dioxide and particulate matter. In addition to the natural sources, we'll also briefly touch on the anthropogenic sources as well as control measurements to manage these atmospheric air pollutants. The historical context to Americans' exposure to particulate matter and the associated health effects hasn't been studied until just recently. Americans exposed to the 1930s Dust Bowl in early life suffered permanent and meaningful damage to their health and human capital, according to research that was presented to the Economic Historical Society in 2015. The study finds that people exposed in the earliest developmental stages, particularly in utero, were the most sensitive to the Dust Bowl's negative effects on health, and they have suffered the worst outcomes as adults. In particular, the findings indicate that timely and substantial policy interventions can aid in recovery from natural disasters. They provide insight into when and how child's development and these investments are likely to be most effective. The Dust Bowl of the 1930s, during which a series of massive dust storms ravaged the Great Plains, destroying agricultural lands and causing injury to health and nutrition, was one of the most devastating environmental catastrophes in American history. Understandably, the crisis still looms large in American popular culture, with contemporary artists evoking the grinding poverty and despair that the Great Plains farmer and migrant mother and the struggling everyman. But whatever became after the dust settled? Particulate matter, usually abbreviated as PM, is the representative term for the mixture of solid and liquid droplets that are found in the air. Examples include dust, dirt, soot, or smoke, and even though they can be large, they can also be smaller than what can be seen with the naked eye. Two examples include PM10, which is inhalable particulates with diameters that are usually 10 micrometers or smaller, and then P2.5, which is the fine inhalable particles with diameters that are very small, 2.5 micrometers or smaller. Sources of particulate matter include all kinds of chemical solvents that are usually emitted from source pollutants such as construction sites, unpaved roads, fields, smokestacks, or fires. And most of these particulates form in the atmosphere as a result of complex reactions of chemicals such as sulfur dioxide, nitrous oxides, and these pollutants are usually emitted from fossil fuel combustion or internal combustion engines like that from automobiles. There are a number of adverse health effects that is associated with particulate matter. The size of the particle is directly linked to the potential for causing these health problems, and interestingly, the small particles, those that are less than 10 micrometers, actually pose the greatest risk to human health. Examples include premature death in people with heart or lung disease, non-fatal heart attacks, irregular heartbeat, aggravated asthma, decreased lung function, and increased respiratory symptoms such as irritation in the airways or coughing or difficulty breathing. In the environment, these particles can be carried over long distances, carried by trade winds, and they usually settle on the ground or in water. Depending on their chemical composition, the effects of particulate matter settling may include making streams and rivers less acidic, changing the nutrient balance in coastal waters or river basins, depleting nutrients in the soil, damaging sensitive forest or farm crops, affecting the diversity of all types of ecosystems, or contributing to the effects of acid deposition. Due to the adverse health effects associated with particulate matter air pollution quality control measures are under effect within the United States. The National Ambient Air Quality Standards for particulate matter pollution specify the maximum amount of particulate matter that can be present in the outdoor air. The Clean Air Act requires that the Environmental Protection Agency set a national air quality standard for particulate matter, and in fact it's one of the 6 criteria pollutants that's considered harmful to public health and to the environment. As part of that law, the EPA also periodically reviews these standards to ensure that they provide adequate health and environmental protection, and they also make any updates to these standards as necessary. In an expansive model done by researchers from 1999 to 2015, they found that the reduction in particulate matter since 1999 has lowered mortality in all but 14 counties in the United States. This is a major improvement and a great environmental success story as part of the Clean Air Act. On this slide, I want to take a moment to review the biogeochemical carbon cycle to try to remember what forms do we find carbon in the atmosphere, in plants, in soil, and in animals, and try to understand where atmospheric carbon goes and where does it come from as it exchanges between the biosphere, the pedosphere, and the atmosphere. There's an additional video on the Keeling curve that I would like you to review that can be found on S10.4 on your Canvas page. While you're watching this video, you should think about the challenges that are related to collecting this data, how we can understand this data, and what other types of information are needed to make the connections that we need to make between atmospheric carbon dioxide and global temperature. Likewise, there's another video on carbon emissions across the planet, and while you're watching this video, I'd like you to consider the spatial and the temporal effects of carbon dioxide emissions across the planet.